All right, hello everyone. We are now beginning on chapter 2. So we begin with section 2.1, which is the addition property of equality. So we have three objectives. Our first objective is we want to identify linear equations. Our second objective, we want to use the addition property of equality. And our third objective, we want to simplify and then use the addition property of equality. So we're going to start off our lecture here just with a simple caution. So remember that an equation always includes an equality symbol. So our equation is something like x minus 5 is equal to 2. So we're saying that an equation can be solved where an expression can't be solved. An expression does not have an equality symbol. It is evaluated or simplified. It is not solved. So keeping that in mind as we go through, it's important to recognize the difference between expressions and equations. So with objective 1, we want to identify linear equations. So with linear equations in one variable, or a linear equation in one variable, here it's going to be x, can be written in the form of ax plus b is equal to c, where a and b and c are real numbers or constants, and a is not equal to 0. So for example, some linear equations would be 4x plus 9 is equal to 0, 2x minus 3 is equal to 5, and x is equal to 7. These are linear equations. But nonlinear equations would be anything where we had exponents that were greater than 1 in variables, if we're dividing by variables, or if we had absolute values. So with our linear equations, we're really looking for this form, the ax plus b is equal to c. So recall that a solution of an equation is just a number that makes the equation true when it replaces the variable. So when we find that solution, we just know that when we have some equation, our solution is whatever number we can plug into that variable that would make our statement true. So an equation is solved by finding the solution set, or just the set of all possible solutions. If your equation only has one solution, then your solution set is that one solution in curly braces. So your solution set is just all the different types of solutions that are possible. Then equations that have exactly the same solution set are equivalent equations. So if we have equations and they have the exact same solutions, we can say that those equations are going to be equivalent. A linear equation in X is solved by using a series of steps to produce a similar equivalent equation of the form x is equal to a number or number is equal to x. So what we're doing is we want to take some linear equation that's in the form of ax plus b is equal to c, and we want to simplify it into an equivalent equation that's equal to, or that is x equal to some number or some number equal to x. So we want to simplify our expressions down so that we have x is equal to some number is equal to x, where x is being 1x, positive 1x to be even more specific. Objective 2, we want to use the addition property of equality. So in the linear equation x minus 3 is equal to 6, both x minus 3 and 6 represent the same number because that is the meaning of the equality symbol. So we're saying that the expression x minus 3 and 6 are equivalent. So to solve x minus 3 is equal to 6, we change the left side from x minus, I'm supposed to say 3, x minus 3 to just x. So what we see here is we end up with this x minus 3 is equal to 6. This is our given equation. Then, since we want to simplify or isolate our x on our left side, in order to get x plus 0, we need to add our additive inverse of, in this case, we're going to say it's negative 3. And since we did it on one side, we have to do it on the other. Since we know x minus 3 is like saying x plus negative 3, we want to add the additive inverse. So we add 3 to both sides to keep the equation equal and isolate x. So now, and once again, it's like saying plus a negative 3. So since we had a negative 3 plus a positive 3, that's going to leave us with x plus 0. And on our right side, we had 6 plus 3, which is now 9. And that gives us our final answer, which was x is equal to 9. And when we had that one step before our final answer that x plus 0 is equal to 9, and we simplified to just x equals 9, that was using our identity property. So we can always let x equal 9 in our original equation to make sure that it is right. So whenever we find a solution, we always want to plug it back into our original equation to just ensure that our solution is correct. Because we don't know, we could have messed up at some point and it may not actually be correct. But plugging it back into your original equation is the easiest way to check if it's correct or not. So we just want to put 9 or plug 9 in for x into our original equation, which was x minus 3 is equal to 6. So in this case, we get 9 minus 3 is equal to 6, and 9 minus 3 is 6. And we end up with 6 equals 6, and we say that it is correct. So our solution set is just 9 in curly braces. Then we can say we use the addition property of equality above. So what we just did, where we added our additive inverse, this was using our addition property of equality. So our addition property of equality states that if a, b, and c represent real numbers, then the equations a equals b and a plus c is equal to b plus c are equivalent. In words, the same number may be added to each side of the equation without changing the solution set. So we're basically saying that if we add or subtract, keyword subtract here, we can add or subtract numbers to both sides, we keep our equations the same. Whereas if you had scales and you added something to one scale and not the other, we would end up tipping the scales. But if you add the same thing to both scales, your scales will remain the same or equal. So subtraction is also defined as addition of the additive inverse. So we can also use the following rule as well. So the addition property of equality extended subtraction tells us that the same number may be subtracted from each side of an equation without changing the solution set. So now we're extending our addition property to say that we can add or subtract anything from each side of an equation to have our equation remain equal. So using our addition property of equality and our addition property of equality with extended subtraction, we want to solve the equation. We have 4x minus 6 is equal to 5x. So we see here that our x terms are on both the left and the right side. So we'll definitely need to do some simplifying. But let's do this. Let's separate our equation here, and we're going to do a method 1 and a method 2. And we're going to use two different types of ways that we can solve this problem. So we have method 1, and then we're going to leave method 2 over here. So beginning with method 1, we're going to stick with our original equation. So we still have 4x minus 6 is equal to 5x. And now what we're going to do here is we are going to add 6 to both sides. So in this case, we're going to get 4x minus 6 plus 6 is equal to 5x plus 6. If we add 6 to the left side, for the left side to equal to 0, we have to add 6 to the right as well. So since we added 6, this is going to give us 4x plus 0 is equal to 5x plus 6. Since we're just adding plus 0, which is our identity property, we know that this is just 4x is equal to 5x plus 6. And remember now, we want something in the form of x is equal to a number, or a number is equal to x. And we see here with our like terms, 4x and 5x, we need to simplify our expression, and we need x to be on the opposite side of our number. So this tells us that we have to subtract 5x from both sides. And this is going to give us 4x minus 5x is equal to 5x plus 6 minus 5x. And so since we have a 5x minus a 5x, this is just going to become 0 plus 6 on the right-hand side. But then 4x minus 5x is actually going to give us a negative 1x, which is equal to 0 plus 6. And simplifying this expression a little bit further, we get an x, or a negative x is equal to 6. Now the form we want is a positive x is equal to a number. But here we have a negative x is equal to a number, which is a little strange. So we're going to table this method for now. We're going to come back to what this means. And we're going to go on to a method 2. We're going to try out another method here. So with our other method, starting with our original 4x minus 6 is equal to 5x, what we're going to do instead is let's go ahead and subtract 4x from both sides and see what happens then. So if we subtract 4x from both sides, we're going to get a 4x minus 6 minus 4x, which is equal to 5x minus 4x. Since we have 4x minus 4x, this is just going to become 0 minus 6, which is equal to 5x minus 4x, which is just positive x, or 1x. Then, since we just have 0 minus 6 is equal to x, we can simplify and get negative 6 is equal to x. So now we have the form that we want. We have some number is equal to x. So we're going to state that this is the solution. We want to check and see if it's correct. So we've used our method. Now let's check. We're going to be plugging negative 6 into our original equation. So we're going to say 4 times negative 6 minus 6 is equal to 5 times negative 6. 4 times negative 6 is going to be negative 24. Minus 6 is equal to 5 times negative 6, which is negative 30. Negative 24 minus 6 is like saying negative 24 plus negative 6, which is going to give us negative 30 is equal to negative 30. And we have here that is correct. So our solution x is equal to negative 6 is correct, since we checked our answer and we got that negative 30 was equal to 30. So we know that our answer is x is equal to negative 6. Thinking about our other answer that we got from method 1, we got negative x is equal to 6. And that's pretty similar, except the negative is on the wrong side. From example 1, when we added 6 to both sides, our equation results in a negative x is equal to 6. Negative x is technically the additive inverse of x. So x is equal to the additive inverse of 6, which was negative 6. So we ended up getting that x is negative 6 from our method 1. We're saying that these statements are equivalent. So we get that this becomes x equals negative 6. We can also make the following generalization. If a is a number and negative x is equal to a, then x is equal to negative a. So moving forward in the future, if we ever get something like this where we get a negative x is equal to some number, we can change this into x is equal to negative of whatever that number is. So all right, as a note here, there are often several correct ways to solve an equation, which is the same thing as we just showed. We had 2 different methods for solving the same equation. We got the same answer. So we could begin by adding 6p in our example here below, instead of 7p to each side of the equation. 8 minus 6p is equal to negative 7p plus 5. And then once you see example 6 in the book. So combining like terms and subtracting 5 from each side gives us 3 is equal to negative p. And if 3 is equal to negative p, then negative 3 is equal to p. And the variable has been isolated on the right-hand side of the equation, and the same solution results. So similarly to what we just had, this is all to say that there are different ways to solve an equation. You don't have to solve it in one exact way, but either way you should get the correct answer as long as you are doing the correct steps. So moving on to objective 3. For objective 3, we just want to simplify and then use the addition property of equality. So for an example 2, we just want to solve our equation, with our equation being 3 times 2 plus 5x minus 1 plus 14x is equal to 6. So let's go ahead and solve this equation. So we see here in our first term, our 3 times 2 plus 5x, We want to use our distributive property because ultimately we want to combine our like terms and then try and solve for x. So using our distributive property, we can say this is the same as 3 times 2 plus 3 times 5x. Now we have subtraction. Subtraction we say is the same as saying plus the additive inverse, or plus negative. So we're going to have a plus negative 1 plus 14x is equal to 6. So in our next step, we're going to need to distribute our negative as well. So for our next step, we're going to leave our multiplication terms alone for now. And now we're going to distribute our negative. So this gives us a plus negative 1 and a plus negative 14x is equal to 6. So now we have that each one of our terms are being added together. And now we want to do our multiplications. So our first terms here, 3 times 2 is equal to 6. Oops, 6. Plus 3 times 5x, which is 15x. And then we have plus negative 1 and plus negative 14x is equal to 6. So we have like terms. We have 15x and negative 14x are like terms, and 6 and negative 1 are like terms. Since each one of our terms are being added together, we can use our commutative property to rearrange. So let's rearrange our equation here. I blanked, I almost said expression. So we can rearrange our equation. So let's start with 15x. You know our equation, we want it to kind of look like ax plus b is equal to c. So if we're rearranging anyway, let's just put our variables in the beginning. So we have 15x plus negative 14x plus 6 plus negative 1 is equal to 6. So let's simplify. 15x plus negative 14x is going to end up giving us 1x, or positive 1x. Then 6 plus negative 1 is the same as saying 6 minus 1, which is equal to 5. So now we have that x plus 5 is equal to 6. And we have a pretty simplified equation. We just want to solve for x, so let's subtract 5 from both sides. So now we're going to get x plus 5 minus 5 is equal to 6 minus 5. Then we end up getting x plus 0 is equal to 6 minus 5, which is just 1, and x plus 0 is just x. So we have x plus 1. And x plus 1 we want to say is our solution, but let's check. So let's do our check now. We're checking for when x is equal to 1. So we're going to have 3 times 2 plus 5 times 1 minus 1 plus 14 times 1 is equal to 6. So let's simplify. Anything in our parentheses first. So 2 plus 5 times 1 is just 5. And then we have minus 1 plus 14 times 1, which is just 14, all equal to 6. Now we want to add what's in our parentheses. 2 plus 5 is equal to 7, and 1 plus 14 is 15. Now we just have our last operation to do, or second to last operation, which is 3 times 7. So we have 21 minus 15, we're saying is equal to 6. And we do see that 21 minus 15 is 6. So when we checked here, we did get that 6 was equal to 6, so therefore x equals 1 is our solution. Just as a final caution, the final line when checking is not your final answer. It's merely the confirmation the solution you found is correct. So dragging this caution up here a little bit closer to our problem. So we're saying that this 6 equals 6, this is not our final answer. 6 is not our final answer. our solution was x equals 1. So when we do our check here to make sure that our equation was equal to whatever number we had set equal to, we're confirming that x equals 1 is a solution. Our final answer is not whatever it was equal to. Final answer in this case is not 6, it is x equals 1. So just remember to keep those straight, especially in doing problems in my math lab, especially. So all right, next section we'll be doing section 2.2. So I'll see you all then.